All righty. So, continuing what we did a week ago. Yes, it was already a week ago. Was the last time that we had class. If you could factor this one completely for me, and then let's see what we got. See what we remember from a week ago. Okay, go for it. First thing that we look for when we're factoring, we look for a greatest common factor. So I'm looking at 8 and 18. Between them, I can for sure take out a 2. Then I'm looking at the variables. Between x to the 4th and x squared, I can take out an x squared. That's going to leave me then with 4x squared and minus 9. There? Huh? Am I done? Yes. Yes? Okay. Do we all agree that we are done? We've factored completely. The kicker was this completely word up there. We have factored, yes, but have we factored completely? What do we got, Pete? Not only because it's the minus sign should be the ding 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 1, but 9 is a perfect square, right? Is 4x squared a perfect square? Yeah, because 4 is a perfect square and x squared is a perfect square. So that's going to factor completely into the 2x squared is going to come along for the ride. Then we're going to have 2x minus 3 and 2x plus 3. And that, ladies and gentlemen, is it factored completely. Now, if you had the plus 3, 1 come first, and the minus 3, 1 come second, that's fine. That's the same thing. Okay? All right? Proud of you. Okay? Okay? So again, if you stopped here, you factored. But the direction said factor completely. So that's the next step. Okay? We have one more style of factoring to go, and that is factoring by grouping. Okay? Now, factoring by grouping is only going to work if you have an even amount of terms. Okay? So if you have 4 terms, or 6 terms, or 8 terms, or 10 terms, a larger total of number of terms, but it has to be even. Okay? So the first thing that you are going to do is you are going to have to write your polynomial in standard form. Now I know it's been a while. It's been a minute or two. What is standard form of a polynomial? Yes, ma'am. So the term with the biggest exponent comes first, and then the next biggest, all the way down, and last would come just our numbers. Right? Yep, exactly. Okay? Right? So that has to happen before we can factor by grouping. Okay? Then what you do is you cut your polynomial in half, which is why you have to have an even amount of terms, because otherwise you can't cut it in half. Okay? So you got to have an even amount of terms, so we cut that in half. And then what you do is you do 3 greatest common factors. Oops, I put 3, but then I forgot to say actual. You actually do 3 of them. It is step 3, but you do 3 greatest common factors. So the first one is going to be your left half. The second one is going to be your right half. Again, because you cut the polynomial in half. And then your last one is going to be both of those. So here is our first example. Okay? It has 4 terms. Agree? Okay? Which means I don't have a, well, first off, can I GCF anything out of all of those 4 terms? No, they all don't have an x, and they all don't share a common factor in terms of a number. Okay? So that's out of the picture. Then the next thing we were supposed to look at was the difference of perfect squares. Well, it's got 4 terms. It doesn't have 2 terms. The next thing we were going to look at was trinomial factoring, the 2 sets of parentheses, the butt cheeks is what we called them last week. It's got 4 terms. That's not a trinomial. Next one was sum or difference of cubes. Okay? Again, 4 terms, not it. So the only thing that's left for me to, or the only way that's left for me to factor is by grouping. So step number 1 says we need to write it in standard form. Do we have it written in standard form? Yes, so that's done for us. Second step says I cut it in half. So shabam, I cut it in half, right down the middle. 2 terms in this case on each side. Okay. Then I need to GCF the left side. Okay. What can I factor? So now, let me bring the shade over here a little bit. So now, what can I GCF out of just those 2 terms? X squared. Okay. What's left over? X minus 7. Okay. Then I need to GCF the right side. What can I factor out of that? 8. Okay? So if I factor out an 8, what's left over? X minus 7. Okay? Now, what I have to do is my third GCF is I have to GCF both of those combined. What factor shows up in both of those terms? X minus 7. So I can factor out the x minus 7, and what's left over? X squared plus 8. Okay? Now, because we are complete factorers, now we have to look at these 2 terms, and can anything be factored out of those 2 terms? So let's look at x minus 7 first. Can anything be factored from it? No. X squared plus 8, can anything be factored from it? No. So since nothing else can be factored out of it, then that is our complete factored by grouping form done, did, box. Okay? Good times. You try that one. So this one's got 4 terms, so I'm going to factor it by grouping. So first I'm going to, oops, I forgot to divide it in half right away, right off the start. Okay, so I'm going to do that right there. Love it. Okay, so the first, I can factor out 9t squared. And then that's going to leave me with 3t plus 5. Do you agree with that one? Okay. Second one, I can't factor out any number, but I need it to be 3t, so I'm going to factor out a -1. And that's going to leave me with 3t plus 5. I can do that. Okay. Now when I go to factor this whole thing, both of them have a 3t plus 5, and I'm left with 9t squared minus 1. But that 9t squared minus 1, that in itself is a perfect square minus a perfect square. So then this would be 3t plus 5, and then 3t minus 1, and 3t plus 1. And now none of them can be factored anymore. And that's my complete factorization. Questions, comments, concerns? You can hang it right on the pencil sharpener, then people can see it better. Thank you. Good? Love it. Okay? Factoring, factoring, and factoring. Let's get done with factoring, and because we'll still be using factoring when we're going on here in the next stuff. But now let's solve equations. So now we're going to come up with solutions to the equation. What makes the equations be true? Up to this point in time, we've been dealing with expressions, no equal sign. Now, so on Friday's formative, next week's quiz, the following week's, I think it's the following week, maybe it's 2 weeks, I don't remember, test, it's your job to decide what you've got to do. If you see an equal sign from now on, you are solving. If you see just an expression, you're factoring. Okay? All right? So the very first thing that we need to talk about is the fundamental theorem of algebra. And the fundamental theorem of algebra says that the degree of a polynomial equation indicates the total number of solutions, real and complex, that exist. So what that's saying is, well, first off, what's the degree of a polynomial again? Talked about it already. What's the degree of a polynomial? What's the degree of a polynomial? Talked about it on the day that we talked about end behavior. Day 2, 3.2.
The first exponent?
Not the first exponent.
The last?
Not the last.
The second.
India? The biggest exponent. Okay? So the fundamental theorem of algebra says that the degree, okay, or the biggest exponent indicates, what indicates? Tells you. Okay, it's how many, okay? So it tells you, so the degree, the biggest exponent, tells you how many answers you need to get, because solutions are answers, okay? So if your biggest exponent is 3, you've got to find 3 answers. If your biggest exponent is 1, you only got to find 1 answer, okay? Now, those are both real and complex. Today, we're just going to be dealing with real ones. Okay? Later on next week, we'll go into the imaginary land, and we'll deal with complex ones. Okay? But for right now, we just need to get real solutions. Okay? So how we're going to do that is we're going to factor our equations. Now, with factoring, sometimes things aren't factorable, so we have to remember our old dear friend, the quadratic formula. Okay? Now, the quadratic formula only works on a quadratic equation. So this only works if it is ax squared plus bx plus c equals 0. That's the only time that it works. Okay? It won't work on a cubic. It won't work on a quartic. It only works on a quadratic. The other mathematical property that we are going to be using is something called the zero product property. And the zero product property says that if you've got two things or more that multiply together to be 0, one of them or all of them have to be 0. Which you've seen before, you just probably didn't know that was actually called the zero product property. Okay? So here is our next example. We now have an equal sign, so we can solve. Because we have that equal sign, that means solve. Okay? So let's plan our work so that we can work our plan. So the first step in your plan is it has to be equal to 0. You don't get a choice in the matter. You have to set your equation equal to 0. Have to. There's no other way to solve. Okay? So in this particular case, I would add 36x to both sides. So that's going to give me 4x to the 5th minus 40x cubed plus 36x equals 0. Have to. In all cases. Second step says that you need to now factor completely. Is there a GCF that we can do on the left side? What can we factor out? 4x. What's left over? X to the 4th power minus 10x squared plus 9. Are we factored completely?
No.
No? Can we factor x to the 4th minus 10x squared plus 9? To what? Do we agree? Yes? Okay. Are we factored completely? Who said no? What you got, Hannah? And? x squared is a perfect square, and we'll stay on the left one. The third part of that is that there's a minus sign. So yep, so that's a perfect square minus perfect square. Now we'll go back to the other one. What about x squared minus 1? Perfect square minus a perfect square, right? So this one can be factored all the way down to 4x, x minus 3, x plus 3, x minus 1, x plus 1. Okay? So now we are factored completely. Okay? Sometimes you gotta factor until you can't factor anymore. Okay? Now, here is the wonderful part of step 3. Step 3 says now to solve it, you set each of your factors equal to 0 and solve it. And a side note, here would be where your quadratic formula would come into play. Okay. Starting on Wednesday, you two can't sit next to one another for the remainder of this week.
Okay.
Okay? Because every time I turn around, all I can hear is you two talking.
Okay.
Okay?
Got it.
Okay? So this would become 4x equals 0, x minus 3 equals 0, x plus 3 equals 0, x minus 1 equals 0, and x plus 1 equals 0. We set each of those factors equal to 0. So this one becomes x equals 0. X is 3, x is negative 3, x is 1, and x is negative 1. So we have 5 answers here, right? Well, we knew that, if I scroll all the way back up, we knew that right from the start because the biggest exponent was, that's a bad box. The biggest exponent was 5. So we knew we had to come up with 5 total answers. Okay. Now, in the end, if you wanted to write this as negative 3, negative 1, 0, 1, and 3, or if you wanted to write it as 0, plus or minus 3, plus or minus 1, either one of those works for writing them all out, or if you have the pair, the positive and the negative pair, you can. Okay? Questions on that? You try this one. So step number 1, what do we got to do first? Got to get it equal to 0, so I have to add 4x squared to both sides. So that's going to give me x cubed plus 4x squared minus 10x equals 0. Then it says factor completely, correct? Okay, what can I factor out? An x, okay? So if I factor out an x, that leaves me with x squared plus 4x minus 10 equals 0. Agree? Okay. Can x squared plus 4x minus 10 be factored? Two numbers that multiply together to be negative 10 and add to be 4. No, right? Okay. So we are factored completely. Yes? Okay. So step number 3 then says we have to set each factor equal to 0. So we're there. Since x squared plus 4x minus 10 is not factorable, that means that we have to use the quadratic formula. Okay. So then this is going to be x here is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 4 squared, 16. 4 times 1, 4 times negative 10, negative 40. 16 minus negative 40, 56. Yes? Okay. Can the square root of 56 be simplified? Is there a perfect square factor that goes in the 56? What do you got, Raya?
Madison 4.
4?
Yeah.
Yeah. Yeah. And she didn't even look up. And she didn't even look up.
No. Oh.
I was giving you the answer right here by my finger. Okay? So what's the square root of 4? 2, right? What is 56 divided by 4? 14. Can that fraction be simplified? That one right there. Yeah. Funny ears, right? Okay. So then this would be negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. So we're left with that. So our answers here are, remember we needed 3 answers. One answer is 0. One answer is negative 2 plus the square root of 14. The other answer is negative 2 minus the square root of 14. Those are our 3 answers. All of them are real. Okay. One last example, because it has a different style of problem that I would like to go over. Okay. So we've got x cubed plus 3x squared plus 5x plus 15 equals 0. Step number 1, done for us. It's already equal to 0. Okay. Step number 2 says we need to factor this completely. Okay. Well, it's got 4 terms, so we're going to divide it in half. That's that grouping way we learned at the beginning of class today. First one, I'm going to factor out an x squared. Going to leave me with x plus 3. Second one, I'm going to factor out a 5. That's going to leave me with x plus 3. Then I need to factor the whole thing. I can factor out an x plus 3, leaves me with x squared plus 5. Can x squared plus 5 be factored? Nope. So we're factored completely. Yes? Okay. So then we set our factors equal to 0. Yes? First one gets solved, and it's -3. Do we agree with that? Okay. Second one gets solved. I'm going to subtract 5 from both sides. That's going to give me x squared equals -5. And then I can do what to both sides? I can square root both sides. So I would get here x equals, what's wrong with the square root of -5? Can't square root of negative. That's one of those imaginary type numbers, right? So this would be plus or minus, if I was actually doing it, if it was next week, I times the square root of 5. But the question, or the problem I should say, said find only the real solutions. So the only real solution to this one is -3. Yes, we found 3 solutions, but it's only asking for the real ones. So for right now, until we get to it later on next week, we are not doing any square roots of negative numbers. Okay? We'll save that for next. Okay? So looking forward to this week. On Wednesday, we're going to be dealing with dividing polynomials. We're going to do long division of polynomials because we need to do it for NTC. Okay? So we'll deal with that on Wednesday. Thursday, I am going to be gone, and so it's going to be a Chromebook and EarPod type of a day. There'll be a video for you to watch in class and take notes on. It'll be more solving and factoring type things of that kind. Then on Friday, once again, I will be gone on Friday. So the week 9 homework, which you picked up today by the candy jar, that's due this week Friday. In terms of right now, you can try all of them on the front side. You know how to do everything on the front side. Back side is Wednesdays. You can try them if you want, but that's not until Wednesday. And this week, Friday, you will have a formative assessment in class on Friday. Okay? Good times.